Hey everyone, welcome back to my channel EduVibe. Today we will start with the last topic of the position fields, and we finally completed unit today. So which is electromagnetic induction, and we do one law which is the Hessen's law. So this is a small topic, and we probably take the questions like the direction one, which we did in a left hand rules, that we have to find the direction where that goes, where it gets come. So that's the question you get in this, and this is the same thing, but we involve the like we do with the solenoid, the current carrying the solenoid, but now we're using the magnet instead of the solenoid, but the rest of things the same. So this involves the magnets and the electrical thing which goes to the induction of the electromagnetic induction. So let's learn that what is that and how can this has been discovered. So electromagnetic induction is the process of producing induced maximum voltage in a conductor. So to produce the induced maximum voltage of conductor is called the electromagnetic induction when the magnetic flow is leaking into the conductor of charges. So it's conductor of the changes when in involved, and we find the produced maximum voltage in conductor is just a small definition. This is called electromagnetic induction. So the simplest version for the Fedros and the Harris experiment was that took a bar magnet and passed to a galvanometer. So it's a galvanometer. So this is like this one. So there's a small type of tile on it, and this has like coiled wire. And when we put that magnet into this, something happen which will lead to the induced maximum voltage of that thing. That meter shows the voltage of that magnet, or they perform the induced maximum voltage in the conductor when they put that magnet into it. We do some question related to this, that's how this works. Then I noticed that induced electric current, which has noticed by a deflection of the galvanometer's needle. So you see the deflection in this. So when they see a deflection of this, so they conclude from that the when the bar magnet moved in the opposite direction. It moved in opposite direction. Then the needle of the galvanometer deflected opposite direction, and the indirect current has now induced in opposite direction. So when they notice that when we put the bar magnet, when we put a bar magnet opposite direction to it, so the needle of the galvanometer shows the deflection sign. So the deflection will show that the current is induced in the opposite direction. So when we put the bar magnet in opposite direction, so your current is also in the opposite direction in that case. If the magnet has held a stationary in the galvanometer, no current has induced. So if this is stationary, so nothing will happen. It can't do any inducement. The production of the electricity using the magnetism is known as the electromagnetic induction or the generator effect. They are also known as the generator effect or the electromagnetic induction. That production is called that. So from here we will move on to the Haynes laws. So Haynes is the again the law which involves that experiment in the other terms. So with that term, so they say is that the direction of the magnetically induced current in as such as to oppose the cause of the current is called the Lenz's law. So if the any magnetically induced current direction is such that which oppose the cause of the current, which will cause the current in any type of thing in the magnetical one, in the magnetically induced current is known as the Higgs law. So it's more like sufficient way that the magnetic field increases, then induced current creates a field that opposes that increase. So if the magnetic field increases, so induced current of that field is opposes the also increases. So if the magnetic field decreases, so that induced current erases the field that tries to keep it more decreasing and decreasing. So increases and increases, decreases and decreases is dependent on the magnetic field and the current induced in the wire. The system is the change, which is called the conservation of energy principle. So in that way, conservation of energy principle is existed that change. So Heinz law must oppose the motion of the object producing the change to the respect to the law of conservation of energy. So this has to be in the change conservation of energy, not like resist that change. So that production or the opposement it should be according to the conservation of energy law. So that's the all the thing, and this both are talking about the induced current or the magnetic field involved in this. So this is more like the theory based thing we have to just know, but that type of diagram you commonly seen for the Haynes law, that if we have like bar magnet, this has the bar magnet, and the lines of force will originate from the south, and there's a no current in the loop yet. When you put that magnet into that thing, when the magnetic field go into that loop, so what you can see. So we'll see that your magnetic field goes like this circular path. You can see the magnetic field induce that current. This means that inducement induction is happening in the current, and when you put that uh, side of this, when you put this over down again to the same direction, so this will change that thing again. So the magnetic field inducement will happen when the magnet going to any loop which has a current on it. So the magnetically and the current and electrically both will combine and produce the induced current in the loop or the wire. So that's the connecting loop is upper length for the Lenz's law. So you got that these type of questions, like as I told you that this is your galvanometer, this one and this one, and you have a magnet on it. So you have to find the bar magnet, electrical coil, and depict the diagrams below. You have to direction of the electron flow through the galvanometer of the each situation. So how this works, we will notice. So first you can see that your this was the motion of the magnet goes like this. So south is over there. When it goes over there, so you have to always that be careful when you're doing that questions. So if that goes over there into that magnet goes over there. So if this is south, this is your south direction. If this is south, so this means your that if it goes in, so this means it's also south. So that is south. So if that magnet is south in that direction and it goes, so this is the galvanometer direction is also this one is south and this one is north. And so when then south, which will do? They will do repulsion. So they will do the repulsion and they opposes the charges. So they oppose the charge, and when that all will happen and motion of the magnet goes in, they will do like this type of thing in that magnet. This will go like coil and coiled, coiled, coil and coiled. It will go like this direction, this direction. So that direction will show the electron flow because electron is flow all to the wire. So what's the direction of this? So this is the right direction kind of. So for this one electron flow is right through the galvanometer. For this one is that again the same thing. So now this is your north and you have that direction always the north over there and south over there. So north and south always keep over there. But now this is the north and goes out. Now this not go like into this, it go motion of the magnet goes over there like this direction. So this goes right direction and this is your south and this is your north. And if they go back, they do the traction in this because if even they go back, but the attraction will happen because this is north and this is the south, and they oppose some charge on it. Opposes the charge. So because of that opposes the charge of this, so this means that again they do the same thing, that they again do that kind of electron flow. That kind of electron flow you have in this again. So this means you have a electron flow is again right. Is again right through the development. So that's the small thing, and I know this is like the kind of tricky part in this, but you have to like be careful regarding to that question because you get if you get like in that type of thing, you get the 1 or 1.5 marks for that one question. But like if it's actually is a 1 mark question, you get the 4 options, and you have to choose that what's going on regarding to the question in that whole thing. So that's the thing you have to know in this. That's all for this lesson. So we completed that unit and now we're doing the practice question of magnetic field first. Then we do diploma questions and then we officially submit that unit. So learning by simple EduVibe, learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till next time, I did with EduVibe.